We have weighed black holes, listened to neutron stars collide, and watched light bend around galaxies 13 billion years old. We can measure the heartbeat of the universe to a fraction of a degree. And yet, right now, as you breathe, our entire galaxy is being dragged through space at over 2 million kilometers per hour towards something we cannot see. It sits behind the Milky Way's own body, in a blind spot we call the Zone of Avoidance. It should be just more galaxies. It turns out to be something far larger and far stranger. And the deeper we look, the more it feels like we are falling. Subscribe, and let's follow the pull. You are not standing still. You are not even simply orbiting. The Earth spins beneath you at roughly 1,600 kilometers per hour. It circles the Sun at 107,000. The Sun drags us around the Milky Way at 828,000. And the Milky Way itself is plunging through the cosmos at around 2.1 million kilometers per hour, 600 kilometers every second. We know this because of one of the cleanest measurements in all of physics. In 1977, instruments aboard a U-2 spy plane and later the COBE and Planck satellites found that the cosmic microwave background, the afterglow of the Big Bang, is slightly hotter in one direction and slightly cooler in the other. That tiny temperature asymmetry, the CMB dipole, is our shadow on the universe. It is the universe telling us we are moving. But it does not tell us why. Something is pulling. And when astronomers tried to find what, the map of the sky went dark. When astronomers tried to look in the direction we are falling, they hit a wall. And that wall is us. The Milky Way is a flat disk. And from inside it, our view in the direction of the galactic plane is choked with stars, gas, and dust. Visible light cannot get through. Entire galaxies, entire clusters of galaxies sit on the other side, completely hidden. Astronomers gave this curtain a name that sounds like a horror title, the Zone of Avoidance. It covers nearly 20% of the entire sky. Picture standing in the middle of a vast empty field at night, and someone has tied a thick black blindfold across the lower half of your eyes. Whatever is approaching you across that field, you cannot see. And of course, of all the directions in the sky, the thing pulling our galaxy sits almost exactly behind that blindfold. To find what was tugging on us, astronomers would have to learn to see through our own home. In the late 1970s and through the 1980s, a small team of astronomers set out to do exactly that. They called themselves, half-jokingly, the Seven Samurai: Alan Dressler, Sandra Faber, Donald Lyndon Bell, and 4 colleagues. They measured the distances and motions of hundreds of elliptical galaxies, and they found something deeply wrong. The galaxies were not just drifting outward with the expanding universe. They were streaming. Hundreds of galaxies, including ours, were all flowing together in the same direction at hundreds of kilometers per second toward a point in the constellation Centaurus, deep inside the Zone of Avoidance. Lyndon Bell gave it the name that stuck, the Great Attractor. They could not see it. They could only see what it was doing. Something at least the mass of tens of thousands of galaxies was sitting in our blind spot, gravitationally herding us toward it. And the closer they tried to look, the worse the mystery got. For decades, the Great Attractor remained a rumor with gravity. Then, in 2014, the astronomer Brent Tully and his team published a paper in Nature that redrew the map of our cosmic neighborhood. Using the velocities of more than 8,000 nearby galaxies, they traced the gravitational watersheds of the local universe, the lines where matter flows one way versus another. What emerged looked nothing like a list of clusters. It looked like a single sprawling structure, a vast filamentary supercluster 500 million light-years across, containing about 100,000 large galaxies. They named it Laniakea, Hawaiian for immeasurable heaven. And here is the unsettling part. The Milky Way is not at its center. We sit out near an edge. Every star you have ever seen, every galaxy in our local group, every cluster nearby, we are all draining inward, downhill, toward the gravitational floor of Laniakea. And sitting near the bottom of that valley, exactly in the zone of avoidance, is the Great Attractor. But Laniakea was not the end of the slope. When astronomers used X-ray telescopes and radio surveys to peek through the dust of the zone of avoidance, they finally caught glimpses of what was hiding there. They found the Norma cluster, a dense knot of galaxies sitting roughly where the Great Attractor should be. Massive, but not massive enough to explain the pull. Because behind it, another 250 million light-years deeper into the dark, sat something even bigger. The Shapley Supercluster. Named after the astronomer Harlow Shapley, who first noticed an overabundance of galaxies in that direction back in the 1930s, Shapley is one of the largest concentrations of mass in the observable universe, a swarm of more than 8,000 galaxies bound together in a region so dense it warps the flow of the cosmos around it. The Great Attractor, it turns out, is not really the destination. It is more like a way station on a much larger slope. We are not just falling toward a hidden valley. We are falling toward a hidden mountain of mountains. And then a new measurement appeared that made even Shapley look small. In 2008, a team led by Alexander Kashlinsky at NASA Goddard announced something that, if true, was almost too large to think about. By studying the cosmic microwave background, they claimed to detect a coherent motion of galaxy clusters, not just ours, but hundreds of them, stretching across billions of light-years, all drifting in the same direction at around 1,000 kilometers per second. They called it the dark flow. The implication was staggering. Something outside the observable universe, beyond the edge of what light has had time to reach us from, might be tugging on the matter we can see. Later data from Planck pushed back hard. Many cosmologists now believe the signal is statistical noise, or weaker than first reported. But the debate is not over. Whether dark flow is real or not, the Great Attractor is. Shapley is. Laniakea is. The pull is real. And then comes the part that should make your skin crawl. Even though we are falling toward it, we will never get there. Here is the cruelty written into the laws of physics. In 1998, two independent teams measuring distant supernovae, led by Saul Perlmutter, Brian Schmidt, and Adam Rees, discovered that the expansion of the universe is not slowing down, it is accelerating. A mysterious component called dark energy, making up about 68% of everything, is pushing space itself apart faster and faster. On small scales, inside Laniakea, inside our local group, gravity still wins. The Milky Way and Andromeda are bound. The local pull toward the Great Attractor is real and ongoing. But Shapley is roughly 650 million light-years away. And dark energy means the space between us and Shapley is stretching faster than gravity can pull us across it. Our infall toward the Great Attractor will slow. The cosmic web around us will fragment. Distant superclusters will recede into red-shifted silence. We are a stone thrown toward a mountain in a river that is widening forever. We feel the pull. We will never arrive. And in roughly 100 billion years, an astronomer in our galaxy, looking out, will see nothing beyond our own island at all. So this is where we live, not on a quiet little planet in a quiet little galaxy, but on a single drop of light, sliding down the side of an invisible mountain in a river that is tearing itself apart. The Great Attractor is the closest enormous thing we will never reach. The Zone of Avoidance is the curtain we will never fully pull back, and the pull we cannot feel is shaping everything we are. If you could see the Great Attractor with your own eyes for 1 second, would you look? Tell me in the comments and stay with us. The dark has more to show.